What I will try to do in this video is show you an example of how you can treat function as data in any functional language. So I'll use Clojure for this. You can use anything like Haskell, Clojure, and so on. So what I'll do in this, let me show you just a few basic operations. So in like operations involving basic data, and the data structures I will use for this purpose of showing you are vectors. So is a collection as a data structure in Clojure. So you can choose any numbers, and numbers are like this. This is basically a vector. So if you want to assign a name to it, so it will go like this: def vec, and then basically the elements 40 and so on. So this is how you will go about doing that. Okay, so there's okay, so I am basically renaming it. So sorry, reassigning the variable. So that's why it gives me a warning, because it's a functional language. It's pretty big on immutability of variables. So I should have called it something else. So it's before starting this video I assigned vec to something else, I think, or there may be something like there, I think there is like a library function by this name. So let's stop this. Okay, and run again line REPL. Okay, so let's why this runs. This takes quite some time. Okay, it has started, but it is not on yet. Okay, yeah, so now we have it. So let's define a vector. So let's call something, let's call it v, and we'll assign it the data 10 to 300 and 4. Okay, so the variable v is now assigned this vector. So when we try to access it, if we just enter v and hit enter, and we can see the vector that we defined. And now we will show you. Now I will show you how to get an element with index. So for this, there's an inbuilt method called get, and then the vector is v. And then let's say we are trying to access number 300. So it's like 2. The index is 2. So basically 300. That's what we thought we would get, and that's what we get, as pretty much we expected. So what I want to show you here in this video is like how you can treat any function as data. Like that's one of the coolest ideas in functional programming, because you can treat functions as any other data, as much as I understand up to this point anyway. So let's do that. So let's define some functions. So let's quickly define some functions. Let's say square. So square is this, so it basically returns the square of a number. Okay, so this is our square. Let's check. Okay, square of 10 is 100 as expected. So let's define another function. Let's define 2 more functions actually. So let's define cube, and we're not doing like x times square of x. Let's do it in like the primitive way, from the basics, from the primitive building blocks. So this is what our cube function looks like. So this is our cube function. So I'll call this with an argument -3. Let's see how it does. Okay, it's -27 as we expected. So we have defined 2 functions, square and cube. Let's now do one more. So let's define a function called twice. Okay, so let's define a function called twice, and what it does, it, as you can guess from the name, so it just takes a function and it just takes a number and then returns the twice of that. So 2 times x. Okay, so this is it. So our twice function is defined. So twice, let's say 4.6. We multiply 4.6 with twice with 2, we'll get 9.2, as we pretty much expect. And so what's really fantastic about this, that you can actually store this function as data in any data structure. So I'll show you how to store this in a vector. So let's just define this. Let's define a vector. Let's call this vector of functions. Let's name the variable like this, and then we store the functions actually. So square, cube, and twice. So these are the the functions that are defined. So these are actually all functions stored inside a data structure called vector. That's really cool. So if we can apply this, and we can even apply like a function, retrieve a function from this vector, and we can apply this to a number. Let's check that out. So if we do let's retrieve something first. So we have this, then we call vector of functions, and we just want the second one, the cube function. Okay, so we get a function actually. So this, what it is returns is twice. We actually not accessing the cube, because the index of cube is actually 1. So let's so if we can actually apply this function, because when we retrieve the item on the vector called the vector of functions, we get a function returned from that. Okay, and we can apply that function to any data. Okay, so let's do this. So what we did before, so we are getting twice. We will get so this is, we're getting a function. So this part of the code, so this part, get vector of functions, to this part of code, this actually returns us a function, and we can apply this to a value. So what is twice of 30? So see, the 60. So this is a really mind-blowing idea when I first learned about it. So you can treat functions as data and store them in data structures, and then you can retrieve them, and you can apply the return value from a function to another value. Okay, so this is really cool. This is really cool idea. So let's just apply it to something else. So if we have 1, we'll get the cube function. Yes, so 27,000 as we expected. And if we do the square one, so yeah, so we get 900 as we expected. So I think this is really cool, and you can store any function as a value, and then operate on those structures, and then you can also retrieve functions stored in data structure, and you can apply these functions to other values or other functions as well, but I'll not cover that in this video. So I'm sorry, before I go, I really wanted to show you something else, one more concept in Clojure, that is boolean functions that are OR and AND. So what OR does is, you are already familiar with what OR does as a boolean function. So it takes in two values. Let's say nil is always false. Okay, so it takes nil, and it takes a value. Let's say Angela, and so it will return Angela, because Angela has a truthy value and nil is false. Okay, so nil and false are falsy in Clojure, and anything else is truthy. Okay, and there is something more important. If you're coming from Python, for Python, an empty list or an empty tuple or zero all are falsy, but here it's actually not. So let me get something. So let's see, nil, if we supply it an empty vector, what does it return? It returns false, because that's a vector, and it does not behave like a Python empty list. A Python empty list is falsy, but in Clojure it's truthy. So okay, and there is another thing that like I want to tell you, that if all of the values are truthy, let's say 1 2 and 5, all 1 2 and 5 are all truthy, they all return true. So if we do this, so we get 1. So what Clojure does is it returns the first truthy value, because it's the OR operator, it's the OR function. So it does not need to evaluate anything further. Once it finds a truthy value, it knows the expression comes out as true. Okay, so when you run OR on a bunch of arguments that are all truthy, or there are multiple truthy arguments and multiple falsy ones, OR returns the first truthy value. Okay, and does the opposite. If you do this, the same thing with and, it returns it will return 5. Okay, because it's the last one. Okay, because it needs to evaluate all of that, everything in the list, everything, every argument, and if it finds even one that is falsy, then it needs to return false. Okay, so it needs to check everything, and it returns the last one by default. So what happens if we pass our vector? Okay, so our vector of functions, I think it was called yeah, so our so let's go, so if we do this, like, let's just call the functions. Okay, so square, cube, and what we did, twice. So these are all functions. Remember, the square is a function, cube is a function, and twice is a function too, and it will return truth. So these are all truthy values. So functions are values. Okay, so this is a function that we get returned. So let's do this. Let's just apply it. Square, cube, and twice. Okay, so this part of the expression, this actually will return square, because OR returns the first truthy value, and then if we just choose to apply it to the number 20.5, say, okay, so then we get the square one. Okay, not the other way around, not any other functions. So if we just do this, let's do it 20 for simplicity, then 400. So if we just indeed pass, if we pass it to AND, so we know that it will return the last truthy value, so we get 40 as we expect. So this was really cool. So you can store any function in data structures and use them and retrieve them and work with them as data. And you also learned how OR and AND behaves in Clojure. So, and how that and it also evaluates the truthiness of functions as true. Okay, and that's it. I hope you enjoyed it.